All right, so if we look at these and talk through how to evaluate them. First of all, 3 to the fourth has a value of what? 81. And what if you take negative 3 to the fourth? Is that going to be 81 or negative 81? So order of operations says to apply the power first. The base of 4, the power 4 applies to the base of 3 or negative 3? Just the 3. So the negative comes outside. So your answer would be negative 81. Okay, what if you took the entire base negative 3 to the power 4? That has a value of positive 81. And this time the entire base, the whole negative thing, is taken to the fourth. And what if you have a power of negative 4 applied to a base of 1/3? And you can think of it, the negative is going to flip our fraction. So from 1/3 becomes a 3 to the fourth, which you can then evaluate and simplify into positive 81. Okay, what about in example E? 5t to the 0, anything to the power of 0 has a value of 1. And what about 5t to the minus 1? We'll take that whole base and flip it, move it, the base of 5t to the denominator, change its power to a positive. About 5t to the 0. Is that power of 0 now applying to the 5t or just the t? Just the t. So the t to the 0 has a value of 1 times 5 gives us an overall answer of 5. And then finally 5t to the first, all I wanted you to make sure of in this is don't write powers of 1 or 0, actually simplify it out. And so a power of 1 is just the base written by itself. You don't need to have a power to represent that. Right, when we look at the second example here, in the second example you want to rewrite those without using negative powers. Okay, so in this 2 to the minus 4, you can invert your fraction. Your base of 2 gets moved down below, change the sign to a positive 4. Okay, and if you think of this in terms of the expanded form or the reduced form, or the simplified form here, 2 to the fourth has a value of 16. So 1 over 16 would be a better way to express that. Okay, t to the minus 7, the base of t gets moved to the denominator, change the power to positive. Okay, x plus 1 to the minus 2, once again, this negative 2 doesn't apply to the individual terms. Just take the whole binomial, x plus 1, move it to the denominator, change the power to a positive number. And finally, it works with irrational numbers as well. Just take your whole base e, move it to the denominator, change the sign of your power, and you've simplified your expression. Right. The next example 3, when you're looking at simplifying these, you now have the product rule. When you multiply exponents with the same base, what do you do with their powers? Add them. 4 plus 5 is 9. Okay. T to the minus 4 times t, you're still applying the same rules. You add their powers. So a negative 4 and a plus 1 nets you minus 3. If you wanted to write it without using negative exponents, you would have to flip it and put the t, the base t, in the denominator, change its sign to positive. And then finally, if you have two factors that have both a coefficient and variable portion, when you're looking at them, just multiply the coefficients together. 5 times 10 would give you 50, and then apply the properties of their powers. T to the minus 3 times t to the minus 9. You add their powers. Negative 3 plus a negative 9 nets you negative 12. So if you were, again, rewriting this without using negative powers, you have a fraction. 50 is in the numerator. The base t moves to the denominator and change its sign to a positive. All right, and then the final set in these first 4 problems, you're dividing. So dividing 2 exponents with the same base, you subtract powers. Okay, so you can think of this as x, common base x, to the 6 minus 2, which nets you 4. You can also cancel your factors. So 2 of these x's cancel with 2 of these, leaving 4. You get the same answer. Okay, so here, if you're applying the rules, the properties, you have a common base t, so you subtract the powers. 3 minus a negative 7 gives you a plus 10. Okay, or if you're looking to cancel or move, you can move this whole base up to the numerator, change its sign to positive, and now just apply the rules, multiplying, so you add their powers to get t to the 10th. Okay, same idea here. You can either subtract negative 5 minus a negative 7, nets you a plus 2, or you can move this whole base up, becomes a positive 7, multiply, follow the rules for multiplying, which is to add the powers. Lastly, if you take your common base h, negative 2 minus a 2, again when you divide you subtract powers, gives you a minus 4. Or you can move, if you're working with non-negative powers, you can move this down to the denominator, change it to a positive, and you get 1 over h to the 4th. Again, either of those forms is fine, again depending on what form you're asked to put it in. Power to a power. So what are you going to do with the powers here? Multiply negative 4 times 3 gives you negative 12. So you can write your answer in this form. You can also write it in the rational form with a positive power. So here we would move our x to the denominator, change the power to a positive. So either of those forms is okay. In the second example, you have a product. This product has multiple factors, so that power of 2 is going to apply to every single base factor in that product. So it applies to the 5, the x, and the y. So when you apply that power, the base of 5 gets squared, giving you a 25. The base of x cubed gets squared. When you take a power to a power, you do what with the powers? Multiply. 3 times 2 gives you a 6. And then finally, the base of y is squared. So y to the 5th squared, take a power to a power, you get 10. So that would be the simplified form for B. And then finally for C, it's again same idea, except this time you have negative powers. And there's a couple different ways students tend to approach the negative powers. And one set of students will often just apply the negatives individually and kind of go step by step to reduce it. And so if you were working in that process, what you would do is you'd rewrite everything using positive powers. So you might take the base, this whole base in here. You can see that it's a fraction because the negative exponents mean denominator. So if we just set up our fraction for this whole thing to the negative 4, and we look at what we have. 4 is in the numerator. X to the 5th gets moved to the denominator since it had a negative power. The base y gets moved to the denominator since it had a negative power. And the z squared stays where it is. And now you can apply this negative power on the outside, which is basically just going to flip your fraction. So if we take x to the 5th, y to the 6th, move that to the numerator, take 4z squared, move it to the denominator. And so now the sign of that power gets changed to a positive because we use the negative to invert our fraction. And now you apply the power to a power rule as well as the power to a quotient rule. So all bases, x, y, 4, and z will have this power of 4 applied to it. So x to the 5th to the 4th, take a power to a power, you multiply, 5 times 4. Base y to the 6th to the 4th, again multiply powers, you get 24. All over 4 to the 4th, and then z squared to the 4th, when you multiply, or power to a power, you multiply, leaving an 8. Okay, so you can find your answer in this form. And now if you calculate out what 4 to the 4th is, that's fine as well. You could have answered this as 256. I'll talk here in just a second about what powers you should be familiar with without using your calculators. Okay, now, so I said that that's one kind of style or one way that students tend to approach this. The other type of student is the one that just kind of applies the power directly. And so if you apply this power directly and just kind of move base by base, Okay, so let's look at the first base. 4. 4 to the minus 4th is going to put 4 to the 4th in the denominator of a fraction. Apply the power to the next base. X to the minus 5 to the minus 4. Multiply the power so you get a positive 20. That's going to stay up in the numerator. Y, the next base, y to the negative 6 to the negative 4th. Again, you multiply. Negative 6 times negative 4 gives you positive 24. That stays in the numerator. And then our final base, z squared to the negative 4th. When you take a power to a power, you get z to the minus 8. So that z base is going to move to the denominator, change the sign to a positive 8. And so either way, it works just fine. I don't care which method works or which method you want to use, whatever is efficient and makes sense to you.